Hacker! The News Weekly podcast, Top 10 Stories, August 3rd through 9th. Introduction. Welcome to the Hacker News Weekly, where we curate the absolute best discussions from thousands of submissions to bring you the stories that really matter. This week, August 3rd through 9th, we reviewed over 200 stories, and wow, what a week it's been. From OpenAI dropping bombshells that have the community completely divided, to someone spending 6 years building the world's most wonderfully inefficient display, to an entire city achieving zero traffic deaths, we've got innovation, controversy, and some genuinely inspiring engineering. I'm your host, and over the next hour, we're going to dive deep into the top 10 stories that had the Hacker News community absolutely buzzing. These aren't just the highest voted stories. These are the ones that sparked real debate, revealed major industry shifts, and sometimes just made us smile at the sheer audacity of what people are building. So let's jump right in with what might be the most significant AI developments we've seen in months. Part 1. The AI revolution hits home. Let's start with the story that fundamentally changes who can run frontier AI. Moving on to our next story, which has the Hacker News community absolutely buzzing. Open Models by OpenAI. Now, I'll be honest, we couldn't access the actual article link, but honestly, the discussion thread itself tells us everything we need to know, and folks, this is huge. So OpenAI just dropped what they're calling GPT-OSS, open weight models that you can actually run on your own hardware. And when I say your own hardware, I'm not talking about some massive server farm. People are running a 20 billion parameter model, which is near frontier level AI we're talking about, on MacBook Airs, on phones. Can you believe that? Just a couple years ago, we needed cloud infrastructure to run anything remotely this capable. And now you've got people casually firing up what's essentially a slightly smaller GPT-4 on their laptop while sitting in a coffee shop. No internet required, no API costs, no rate limits, just pure, unrestricted AI power at your fingertips. But here's where it gets really interesting from a technical perspective. Some folks are digging into the architecture, and the reviews are mixed. There's this user, Foundry27, who's basically saying, yeah, it's good, but it's not groundbreaking. They're pointing out that compared to what we're seeing from Chinese labs like DeepSeek and Qwen, OpenAI's architecture feels almost conservative. No fancy multi-head latent attention, no shared or routed expert patterns, just solid, reliable transformer architecture that works. And you know what? Maybe that's exactly the point. Sometimes boring and reliable beats fancy and experimental. Now, there's definitely some practical reality checks happening too. One user, Blue Coconut, is reporting that while the capabilities are impressive, they're dealing with 2 to 3 minute pre-fill times that make it feel unusable for actual work. That's rough. Imagine typing a question and then having to go make a cup of coffee while you wait for the model to start generating a response. The future is here, but apparently it still requires some patience. What's really fascinating, though, is the strategic speculation going on. Why now? Why is OpenAI, a company that's been pretty protective of its models, suddenly releasing open weights? The prevailing theory, and I think there's something to this, is that they've got something way better in the pipeline. Maybe GPT-5. Maybe this mysterious O4 model people keep whispering about. It's like when Apple suddenly drops the price on last year's iPhone, you know something new is coming. The democratization angle here is massive, though. We're talking about students, researchers, small startups, anyone really, being able to experiment with near state-of-the-art AI without burning through their savings on API costs. Want to fine-tune it for your specific use case? Go ahead. Want to run it completely offline for sensitive data? No problem. Want to understand how these things actually work under the hood? The weights are right there for you to explore. And the performance numbers people are sharing, look, a 20B model that can compete with much larger models is genuinely impressive. We're seeing this trend across the industry where smaller, more efficient models are punching way above their weight class. It's not just about having the biggest model anymore, it's about having the smartest architecture, the best training data, the most clever optimizations. The fact that this is running on consumer hardware is the headline here. We've crossed a threshold where frontier AI isn't just accessible through cloud services anymore, it's literally sitting on your hard drive. That changes everything about how we think about AI deployment, privacy, customization. The whole landscape just shifted. But speaking of OpenAI and major announcements, the timing of this open model release becomes even more interesting when you consider what else they announced this week. All right, switching gears here. We've got to talk about what might be the most controversial launch OpenAI has done yet. GPT-5 just dropped, and the Hacker News crowd is absolutely tearing it apart. I mean, this thing racked up over 2,000 points and nearly 2,500 comments, but not for the reasons OpenAI probably hoped. So here's the thing. We can't actually access the official announcement page, which is kind of fitting given how this whole launch seems to be going. But the discussion thread tells us everything we need to know. And honestly, it's fascinating to watch the community's reaction unfold. The biggest takeaway? People are calling this barely an incremental improvement. We're talking about minimal benchmark gains that have folks questioning why this even gets to be called GPT-5 instead of, I don't know, GPT 4.5 or something. And get this, the presentation itself had some pretty embarrassing errors. There's apparently a graph about SWE bench performance that's formatted so badly, it's misleading. And this is the kicker, GPT-5 itself confidently explained how airplanes fly using the equal transit time theory, which has been thoroughly debunked. Like, we're talking about an AI system that's supposed to represent the cutting edge of human knowledge, and it's spouting incorrect physics with complete confidence. What's really interesting, though, is what this says about the state of AI competition right now. The consensus seems to be that we're seeing a convergence rather than anyone pulling ahead. Claude's Opus model, Google's Gemini 2.5 Pro, and now GPT-5. They're all performing at roughly similar levels. This completely contradicts that whole winner-take-all AGI narrative we've been hearing for years, doesn't it? Instead of one company racing ahead toward artificial general intelligence, we're seeing everyone hit similar walls. And speaking of walls, there's some technical speculation that's really intriguing. People are suggesting that GPT-5 might not even be a single unified model. The theory is that it's actually multiple specialized models with a router directing queries to the appropriate one. If that's true, it could mean we're hitting fundamental training limitations with these massive language models. Like, maybe we can't just keep throwing more compute at a single model and expect linear improvements anymore. Now, to be fair, and I always try to present both sides here, there are some defenders pointing out legitimate improvements. The pricing is apparently very competitive, and they've bumped the context window up to 400,000 tokens, which is substantial. And there's an interesting argument that even if the raw capabilities haven't jumped dramatically, making the model work better with imprecise prompts could be huge for regular users. You know, the people who aren't prompt engineers and just want to ask questions naturally. But man, the overall sentiment is just disappointment, mixed with a kind of vindication for people who've been saying the AI hype train needed to slow down. One commenter put it perfectly. They said, "This feels like watching the entire industry converge on similar capabilities, rather than anyone achieving a breakthrough." The timing of this is particularly interesting too. OpenAI has been losing mindshare to Anthropic's Claude for months now, especially among developers who care about code quality and reasoning. Google's been making serious moves with Gemini, and here comes GPT-5, supposedly the next big thing, and it's fine. It's just fine. I think what we're witnessing is the end of the era where each new model release was a genuine holy crap moment. Remember when GPT-4 first came out? Or even ChatGPT's initial launch? Those felt like step changes. This feels like, well, like what mature technology looks like. Incremental improvements, feature parity between competitors, and a focus on pricing and implementation rather than raw capability gains. The presentation issues, though, those are just embarrassing. When you're trying to convince the world that you've built the most advanced AI system ever, maybe double-check that your graphs are scaled correctly. And definitely make sure your AI doesn't confidently explain scientific concepts using theories that were debunked decades ago. It's not a great look when the very system you're showcasing demonstrates the hallucination problems we've been worried about all along. Now, while OpenAI is dealing with mixed reactions to their latest releases, there's another fascinating development in the local AI space that's got developers excited. All right, so shifting gears from the cloud to something much more, well, grounded, our next story is I Want Everything Local, Building My Offline AI Workspace. And this one really struck a chord with the Hacker News community, over 1,000 points and 266 comments. You know what's fascinating here? This developer basically said forget it to all the cloud AI services and built their own completely offline AI setup. And I mean completely offline. We're talking local LLMs, sandboxed code execution, even browser automation, all running without touching a single cloud server. The whole thing was sparked by, remember those early ChatGPT days when there was that security breach where people could see other users' conversations? Yeah, that apparently was the last straw for this person. So here's what they built. They're using Ollama to run large language models locally on Apple Silicon, paired it with Assistant UI for the interface. And here's where it gets interesting. Instead of using Docker for sandboxing, they went with Apple's container technology for lightweight VM isolation. They even threw in Playwright for headless browser automation so the system can access the internet when needed, but still under their complete control. Now, the Hacker News discussion on this is, well, it's split right down the middle. On one side, you've got folks who are absolutely here for this privacy-first approach. They're excited about the idea of having their AI assistant that never phones home, never logs their data, never risks exposing their proprietary code or personal thoughts to some cloud provider. But then, and this is where it gets real, there's the practical side. Multiple commenters pointed out that if you want to run anything approaching GPT-4's capabilities locally, you're looking at 80 billion parameter models minimum. That means you need, what, $2,000 plus worth of hardware? We're talking machines with massive amounts of RAM. Some folks mentioned needing 64 gigabytes or more just to run these models at a decent speed. One commenter, TC Dent, really didn't hold back. They called local AI just a fun hobby instead of a viable strategy. Their argument, your expensive hardware depreciates rapidly, the models you can run locally are inferior to cloud offerings, and when you do the math on cost per token, cloud services actually come out cheaper. Plus, they pointed out that services like Cerebras are pushing over 1,000 tokens per second. Meanwhile, your local setup might be chugging along at 20 or 30 tokens per second if you're lucky. There's also this really interesting technical discussion about the knowledge layer problem. Like, okay, you've got your LLM running locally, great. But what about all your personal data it needs to search through? Berkeley's LEANN project came up as a potential solution. Apparently, it can reduce storage requirements by 97% for RAG systems, which could make local knowledge bases more feasible. And here's something that made me raise an eyebrow. Someone discovered that Ollama, which is supposed to be this privacy-focused local LLM runner, was trying to connect to Google domains on launch. So even when you're trying to go completely local, you might still have software that's trying to phone home for who knows what. Analytics, updates. It kind of undermines the whole private narrative a bit. But you know what really stands out to me in this whole discussion? It's not really about whether local AI is better than cloud AI. It's about having the choice. Some people are willing to trade speed and convenience for privacy and control. Others look at those trade-offs and say, no thanks, I'll stick with Claude or GPT-4. The fact that we're even having this conversation, that it's technically possible to run sophisticated AI models on consumer hardware, even if it requires some serious investment, that's pretty remarkable. 5 years ago, this would have been pure fantasy. Now it's just expensive and a bit slow. And speaking of making AI accessible in new ways, there's another project that's taking a completely different approach to the size problem. All right, switching gears here, let's talk about something that caught my eye on Hacker News.
Kitten TTS, a new text-to-speech model that's making waves for being incredibly tiny. And when I say tiny, I mean really tiny. We're talking 25 megabytes. That's smaller than most smartphone photos these days. So here's what's fascinating about this. The developers have somehow crammed a functional text-to-speech system into just 15 million parameters. To put that in perspective, most modern TTS systems are measured in gigabytes, not megabytes. Tortoise TTS, which a lot of folks use for high-quality voice synthesis, that's multiple gigabytes. Even older systems like Tacotron 2 have twice as many parameters just for their acoustic model alone. And the really cutting-edge stuff, like Val-E, we're talking billions of parameters there. What really sets Kitten apart, though, is that it's CPU only, no GPU required. Think about that for a second. You could theoretically run this on a Raspberry Pi Zero, on some ancient laptop gathering dust in your closet, maybe even in a web browser without any server-side processing. The developers are claiming it runs at about 5 times real-time speed on consumer CPUs with around 315 milliseconds of initial latency. That's actually pretty impressive for something this small.
Now, the Hacker News crowd, they're having a really interesting debate about this. On one hand, you've got people who are absolutely thrilled about the Apache 2.0 license combined with this tiny footprint. They're imagining voice-enabled IoT devices, talking toys that don't need internet connections, privacy-focused applications where you don't want to send audio to the cloud. One commenter mentioned they could finally add voice to their project without worrying about GPU requirements or cloud dependencies. But, and there's always a but, right? The quality discussion is where things get interesting. Look, nobody's claiming this sounds like Scarlett Johansson or Morgan Freeman. The consensus seems to be that it's acceptable for the size, but not quite ready to replace existing solutions. Several users compared it to Piper, another lightweight TTS system, and the reviews were mixed. Some found Kitten slightly better, others preferred Piper's output. There's this fascinating tension in the comments between two camps. You've got the pragmatists saying, hey, for 25 megabytes running on CPU, this is incredible. And then you've got the quality-focused folks pointing out that with modern alternatives like F5 TTS or Fish Speech, you can get significantly better quality on modest hardware, even just 6 gigabytes of VRAM. So why compromise? One particularly insightful comment pointed out something that might burst the bubble a bit. While the model itself is 25 megabytes, once you factor in Python dependencies and everything else you need to actually run it, the deployment footprint grows considerably. It's still small compared to alternatives, but maybe not quite as revolutionary as that 25 megabyte number suggests. What I find really compelling about this, though, is what it represents for the broader trend in AI. We're seeing this push towards smaller, more efficient models across the board. Not everything needs to be ChatGPT scale to be useful. Sometimes you just need something that works, that respects privacy, that can run anywhere. Okay, switching gears here, let's dive into something that's got the Hacker News community absolutely buzzing. Genie 3. A new frontier for world models from Google DeepMind. This one pulled in nearly 1,500 points and almost 500 comments. And honestly, after digging through this story, I can see why people are so divided on it.
So here's what we're looking at. Google DeepMind just announced Genie 3, and they're calling it a breakthrough in general-purpose world models. What does that actually mean? Well, imagine typing in a text prompt like a cyberpunk city at sunset with flying cars and getting back not just an image or a video, but an entire interactive world you can navigate through in real time. We're talking 24 frames per second at 720p resolution, and here's the kicker, it maintains consistency for several minutes, not seconds, minutes. Now, if you're thinking, wait, didn't we just have Genie 2? You're right, and this is where it gets interesting. DeepMind is moving incredibly fast here. Genie 3 is their first world model that allows real-time interaction while actually improving on the consistency and realism compared to its predecessor. But here's where the community starts getting a bit, let's say, skeptical. One of the biggest points of contention in the discussion is that DeepMind dropped this announcement without a research paper, just demos and claims. User RowanGeo77 basically called it out as a wow effect play. arguing that unless you can export these worlds to actual game engines or have some kind of durable interface, what's the practical value? And honestly, that's a fair point. If you can't save these worlds or build on them, are we just looking at a really impressive tech demo? The technical speculation in the comments is fascinating, though. People are trying to reverse engineer how this thing works from the demo videos alone. Some users are analyzing the frame rates, talking about VAE architecture, temporal downscaling, basically doing detective work to figure out what's under the hood. There's this whole thread about whether they're using some kind of video compression techniques or if it's pure generation at each frame. But here's what really caught my attention. DeepMind is positioning this as, and I quote, a key stepping stone on the path to AGI. That's a big claim. They're essentially saying that being able to generate these simulated environments is fundamental infrastructure for achieving artificial general intelligence. The idea is that AI agents could train in unlimited simulated scenarios, learning from rich, diverse environments without needing real-world data. Now, user MDP 2021 had this really interesting philosophical take on this. They're arguing that calling this a world model is actually a linguistic devastation, that we're misusing the term from an epistemological perspective. In their view, a true world model should be about understanding and representing how the actual world works, not just generating plausible-looking simulations.
The limitations are pretty telling, too. We're talking about maintaining consistency for a few minutes, not hours, not persistent worlds that you can return to. The physics simulation is, well, it's there, but users are pointing out it's not exactly accurate. Multi-agent interactions? Not really happening yet. Following complex instructions? Still a work in progress. What's really interesting is watching the community grapple with this shift from open academic research to what feels like closed product development. Several commenters noted that we're seeing this pattern across the industry. Amazing capabilities being announced with less and less technical transparency. One user put it pretty bluntly, the era of open AI research seems to be ending. But let's not lose sight of what's actually being achieved here. Even with all the skepticism, generating interactive, navigable worlds from text prompts at 24 FPS is, that's genuinely impressive. Think about the implications for game development, for VR experiences, for training simulations. Sure, we can't export to Unity yet, and the worlds only last a few minutes, but remember where we were just a couple years ago with AI-generated content. All right, so our next story is hitting on something that's becoming a real flashpoint in the AI world. Perplexity is using stealth, undeclared crawlers to evade no-crawl directives. And wow, with over 1,200 points and 744 comments on Hacker News, this one really struck a nerve. So here's what's going down. Cloudflare, the company that basically protects half of the internet, they've caught Perplexity, that's the AI answer engine that's been trying to compete with ChatGPT and Google, essentially playing a game of digital hide and seek with website owners. And it's pretty wild, actually. What Cloudflare discovered is that Perplexity starts off playing nice, right? They announce themselves with proper user agents, Perplexity bot, Perplexity user, very official sounding. But here's where it gets sneaky. When a website blocks them, instead of respecting that and moving on, they apparently switch identities, different user agents, different source networks, basically putting on a digital disguise to keep scraping that content anyway. And the way Cloudflare tested this is actually pretty clever. They set up these brand new domains that were never publicly accessible. We're talking completely fresh, no links pointing to them, nothing. Yet somehow, within minutes, Perplexity's crawlers found them and started scraping. That's not normal behavior for a search engine that claims to respect website preferences. Now, the Hacker News discussion on this is absolutely fascinating because it's split right down the middle. You've got one camp saying, this is outrageous, they're violating the social contract of the web. And then you've got another group going, wait a minute, if content is publicly accessible, why shouldn't an AI fetch it when a user asks for it? And honestly, that second point is interesting. Several commenters are making this comparison. They're saying, look, when I use Perplexity and ask it a question, it fetches content from websites to answer me.
How is that fundamentally different from me using a browser with an ad blocker? Both ignore what the website wants, both fetch content for the user. Where do we draw the line? One commenter, Skeldrew, actually came out swinging in defense of Perplexity. They're basically saying no crawl directives don't make sense for research tools. If you really want to keep people out, use a login. Public means public. And you know what? There's a certain logic to that, even if it feels uncomfortable. But here's what really matters about this whole situation. We're watching the foundations of how the web works potentially crumble. The robots.txt file, this little text file that's been around since 1994, it's always been more of a gentleman's agreement than an enforceable law. Please don't crawl this part of my site, it says, and for decades, legitimate crawlers have mostly respected that. Now we've got AI companies that are absolutely desperate for training data, and they're looking at all this content behind robots.txt files and thinking, but we need this. And some of them, allegedly including Perplexity here, are deciding that need trumps tradition. The technical skeptics in the comments are having a field day too. They're pointing out that Cloudflare's evidence isn't as bulletproof as it first appears. The screenshots don't definitively prove systematic crawling versus user-directed fetching. Some are suggesting this could be users with browser extensions or automated research tools, not necessarily Perplexity itself doing mass scraping. But even if we give Perplexity the benefit of the doubt on the technical details, and that's a big if, we're still left with this fundamental question. In the age of AI, who gets to decide what's fair game for training and retrieval? Website owners who put their content out there? The AI companies who argue they're just helping users access information? The users themselves who just want answers to their questions? Cloudflare's response has been pretty decisive. They've delisted Perplexity as a verified bot, and they're implementing blocking measures. That's a big deal. When one of the internet's major infrastructure providers basically says, "You're not playing fair," that sends a message. The really wild part is thinking about where this leads. If AI companies keep pushing boundaries, if they keep finding ways around restrictions, we might see a fundamental shift in how websites operate. More paywalls, more authentication requirements, maybe even the end of the open web as we know it. Because if you can't trust that your "please don't crawl this" sign will be respected, well, your only option is to build a fence. But not everything in tech has to be about efficiency and disruption. Sometimes the best projects are the ones that embraced impracticality. All right, so have you ever started a project that got completely out of hand? Our next story is about someone who spent 6 years building what they call the world's most ridiculous wooden pixel display. And honestly, after looking at this thing, I can't decide if it's genius or complete madness. This maker built something called the KiloPixel, a 1,000-pixel wooden display that changes exactly 1 pixel at a time using a mechanical arm. And when I say 1 pixel at a time, I mean it. It moves at the glacial pace of 10 pixels per minute. To put that in perspective, your phone screen has millions of pixels refreshing 60 times per second, and this thing takes 6 seconds to flip a single wooden tile. It's like watching paint dry, except the paint is actively choosing to dry slower just to mess with you. The whole project started when they got inspired by Danny Rosen's unconventional mirrors. You might have seen those viral videos of mirrors made from trash or wooden blocks that somehow reflect your silhouette, and this bizarre e-ink movie player that runs at 24 frames per hour, not per second, per hour. And they thought, you know what? Let's make something even more impractical. What I love about this is the sheer commitment to inefficiency as an art form. The builder essentially created a wall-mounted XY plotter with a 40 by 25 grid of wooden pixels, each one flipping between light and dark. They used extruded aluminum, stepper motors, a Raspberry Pi, all this modern technology to create something deliberately, almost spitefully slow. And here's the kicker. They put it online at kilopix.com, where anyone in the world can draw on it. So you could literally submit a drawing right now and watch it materialize over the course of, well, probably hours. The Hacker News community absolutely ate this up. Over 1,100 points, and the comments are just delightful. You've got this beautiful mix of people who totally get it and are celebrating the absurdity, and then the engineers who literally cannot help themselves from optimizing. Like, there's this whole thread of people suggesting ways to make it faster. Why not flip entire rows at once? You could parallelize with multiple arms, completely missing that the slowness is the entire point. It's like watching someone suggest that Sisyphus should just use a forklift. One commenter, Gysnosis, actually trolled everyone by demonstrating they could create a similar effect in 5 minutes using spray-painted magnetic spheres, which is both hilarious and kind of proves the point about why spending 6 years on this is so wonderfully ridiculous. But then you get into the technical details. The creator had to learn woodworking, CNC machining, 3D printing, web development. This project became a 6-year masterclass in making things the hard way. What really strikes me is how this challenges our entire relationship with technology and efficiency. We're so conditioned to want everything faster, higher resolution, more responsive. And here's someone who spent over half a decade building something that's intentionally worse than a 1970s calculator display. But watching the videos of it working, there's something genuinely mesmerizing about it. Each pixel flip has weight to it, literally and figuratively. You can hear the mechanical arm moving, the satisfying click as each tile flips. Some commenters shared their own mechanical display projects. One person built something with punch cards, another used a thermal printer that scrolls continuously. There's this whole subculture of people building deliberately inefficient displays, and I think there's something profound in that. In an age where everything is instant, where we get frustrated if a web page takes 3 seconds to load, there's something almost rebellious about building a display that takes minutes to show a smiley face.
And I think that's what the community response really shows. We're all so burnt out on everything being optimized for engagement and efficiency that something this purposefully slow and ridiculous feels like a breath of fresh air. It's a 6-year middle finger to Silicon Valley's move fast and break things mentality, built out of wood and aluminum and pure, stubborn dedication to a wonderfully stupid idea. Speaking of engineering making a real difference, let's talk about a city that's using smart design and technology to achieve something that actually matters. All right, so shifting gears from tech to something that's actually using tech to save lives. Our next story is about Helsinki recording 0 traffic deaths for a full year. Yeah, you heard that right. 0. Not a single person died in traffic accidents in Finland's capital city. And the way they pulled this off is fascinating, especially when you look at the tech and data angle. So here's what happened. Helsinki just went an entire year without a traffic fatality, with the last death occurring back in July 2024. And this isn't just luck or coincidence. They've been systematically working toward this for decades. We're talking about a complete reimagining of how a city thinks about streets and transportation. The big headline number that jumped out at me, over 50% of Helsinki streets now have 30 kilometers per hour speed limits. That's about 18 miles per hour for us Americans. And get this, 50 years ago, those same streets had 50 kilometers per hour limits. They literally just slowed everything down. School zones, also 30 kilometers per hour now. It's this gradual, methodical reduction in speed that's been happening over generations. But here's where it gets interesting from a tech perspective. They're using automated speed enforcement everywhere. We're not talking about a cop with a radar gun hiding behind a billboard. This is systematic, data-driven enforcement using cameras and sensors throughout the city. And apparently, the cooperation between city officials and law enforcement on this has been incredibly tight. They're sharing data, they're coordinating responses, they're basically treating traffic safety like a systems engineering problem. The Hacker News discussion on this is absolutely buzzing. Over 1,100 points, 648 comments, and what's fascinating is the cultural debate happening in there. You've got people from Finland explaining that this isn't just about infrastructure. It's about how seriously Finnish culture takes basic safety. Apparently, if you're speeding or driving dangerously, citizens will actually report you and authorities respond immediately. Like, that's just normal there.
Now, some commenters are pushing back a bit, saying, well, Helsinki has 3 times fewer cars per capita than American cities, so of course they have fewer deaths. And you know what? Fair point. But then someone else chimes in that Jersey City, New Jersey also achieved 0 deaths in 2022, so it's not impossible in car-heavy places either. What really struck me, though, is how they redesigned their streets. They're not just lowering speed limits and calling it a day. They've physically separated cyclists and pedestrians from car traffic wherever possible. They've built elevated crossings, narrowed streets, expanded cycling infrastructure, basically making it physically harder to drive fast even if you wanted to. The philosophical shift here is what gets me. 50 years ago, Helsinki was like most cities, prioritizing car throughput, faster speeds, getting vehicles from A to B as quickly as possible. Now they're saying, actually, no, safety first. If it takes you an extra 5 minutes to cross the city but nobody dies, that's the trade-off we're making. And they're using every tool available, urban planning, technology, enforcement, cultural pressure, to make it happen. You know what this reminds me of? It's like when tech companies talk about zero trust security models. Helsinki basically implemented zero trust for traffic. Assume every interaction between a car and a pedestrian could be fatal, and design accordingly. Don't trust drivers to do the right thing. Engineer the environment so the right thing is the only feasible option. What Helsinki has proven is that Vision Zero, this idea that traffic deaths are preventable, not inevitable, isn't just a nice slogan. It's actually achievable with the right combination of political will, infrastructure investment, technology deployment, and cultural shift. And honestly, every city official should be looking at this and asking themselves, why aren't we doing this? Now let's wrap up with a couple of stories about the ongoing battle for control over how we experience the web. And now we've got some interesting news for Safari users who've been waiting for better ad blocking options. uBlock Origin Lite is finally available for Safari, and this is actually causing quite a stir in the community with over 1,100 points and 445 comments on Hacker News.
So here's what's fascinating about this release. uBlock Origin Lite, or uBL as people are calling it, takes a completely different approach to ad blocking than what we're used to. Instead of running a constant background process that's always checking and filtering content, the traditional way that can sometimes slow down your browser, this version is what they call entirely declarative. Basically, it hands over all the heavy lifting to Safari itself. The browser does the actual blocking using its native content filtering capabilities, which means the extension uses literally zero CPU and memory during the actual blocking process. That's pretty clever engineering right there. And before anyone asks, yes, it comes with all the filters you'd expect from uBlock Origin. We're talking Easy List, Easy Privacy, Peter Lowe's ad and tracking server list, the whole standard package that people trust. Early reviews are actually really positive, with a 4.9 out of 5-star rating. One user said it makes Safari feel much lighter than AdGuard, and another called it faster than any other ad blocker they've tried on Safari. But here's where things get interesting, and honestly a bit frustrating for a lot of users. The Hacker News discussion reveals this whole other side of the story that's pretty telling about the state of Safari's extension ecosystem. Tons of people are reporting they literally can't get it to work. We're talking iOS 18.5 users who download it successfully, but then can't actually enable it. There's this weird fragmentation issue where someone might get it working on their iPhone, but not their Mac, or vice versa. One person mentioned needing to update to the latest Mac OS just to get the toggle to appear. What really caught my attention in the discussion thread was how this release has kind of opened up this broader conversation about Safari's ad blocking capabilities in general. There's this fascinating split in the community. Some folks are saying Safari has always been terrible at ad blocking, that Apple is years behind even Chrome's controversial Manifest v3 implementation. But then you've got others jumping in saying, wait, what are you talking about? I've been using AdGuard for years and it works great. One user actually did some testing and found uBlock Origin Lite blocked 94% of ads compared to AdGuard's 79% on the same sites, which those are pretty compelling numbers if they hold up more broadly.
But then again, other people are saying they're sticking with Orion Browser or Brave because Safari's content blocking API is just too limited, no matter which extension you use.
The technical implementation here is worth talking about because it represents this fundamental shift in how we think about browser extensions. By going declarative, uBlock is essentially future-proofing itself against the kind of resource consumption complaints that have plagued ad blockers for years. But it also means working within the constraints of what Safari's content blocking API allows, which, based on the community reaction, might be more limiting than what power users want. What strikes me about this whole situation is it really highlights the tension between Apple's approach to privacy and security, which tends to be more locked down and controlled, and what users actually need to have a good web browsing experience. You've got people in the comments literally switching browsers just to get decent ad blocking, which that's not a great look for Safari, especially when Apple markets itself as the privacy-focused option. And speaking of the web and how we interact with it, let's close with something a bit more fun. All right, so our final story is about an ultra-thin business card that runs a fluid simulation. And honestly, this might be the coolest business card I've ever seen. This thing pulled in over 1,000 points on Hacker News, and for good reason. So picture this. You're at a tech conference, someone hands you your business card, and instead of just contact info, it's running a real-time fluid simulation right there in your hand. We're talking about actual computational fluid dynamics using something called the FILP algorithm, that's Fluid Implicit Particle Physics, running on an RP2350 microcontroller. This isn't some pre-rendered animation or simple particle effect. It's legitimate fluid physics calculations happening on what's essentially a credit card. The technical achievement here is pretty remarkable. The developer managed to squeeze this computationally intensive simulation onto embedded hardware that's thin enough to fit in your wallet. And the design choices are fascinating. They're using this board edge USB-C port design that was borrowed from another maker, CN Lore, who did this Tiny Touch LCD project. So instead of having a bulky USB port sticking out, the edge of the PCB itself becomes the connector. That's the kind of clever engineering that makes hardware nerds like me absolutely giddy.
Now, the Hacker News discussion got really interesting because, while everyone's impressed with the technical side, there's this whole debate about the font choice on the back. I love it when the internet gets pedantic about typography. Multiple commenters were like, amazing project, but that serif font has got to go. And the creator actually jumped into the thread asking for font recommendations. It's such a perfect example of how engineers can nail the impossibly complex stuff and then get tripped up on seemingly simple design decisions. But here's what I think is really fascinating about this project. It represents this broader trend we're seeing, where personal branding in tech is becoming increasingly theatrical. We've moved from paper business cards to NFC cards, and now we're at the point where your business card can be a full computing demonstration. It's functional art, really. The question is this over-engineering, or is it brilliant self-marketing? One commenter, Delichin, made me laugh. They suggested you could just make a water-filled plastic box for way cheaper, and it'd be more realistic. Which, okay, fair point. But that completely misses what makes this impressive, right? Another user, Pornal, jumped in to defend the project, pointing out that a simple water container wouldn't showcase what the flip algorithm can actually do. The splashes, the incompressibility calculations, all that complex physics that makes fluid simulations so computationally challenging. What strikes me about this is how it pushes the boundaries of what we consider practical embedded computing. We're used to seeing microcontrollers run simple sensors or basic displays, but full fluid dynamics, that's the kind of thing that used to require serious computing power. The fact that it's running on a business card, I mean, Moore's Law might be slowing down for cutting-edge chips, but the democratization of computational power continues to blow my mind. But maybe that's not the point. Maybe the point is that in a world where everyone's fighting for attention, where every developer has a GitHub profile and a portfolio site, something like this cuts through the noise. It's memorable, It starts conversations. And honestly, if you can build something like this, you probably don't need a traditional resume anyway. The card itself is the resume.
What strikes me about this week's stories is how they capture this moment we're in, where the bleeding edge of technology is becoming accessible to individuals, where the ethics of how we build and deploy these systems is just as important as the technical achievements, and where sometimes the most interesting projects are the ones that reject our obsession with efficiency altogether. The convergence we're seeing in AI capabilities, the push for local computing, the battle over web scraping ethics, the proof that Vision Zero is achievable. These aren't just tech stories. They're stories about choices. Choices about privacy, about safety, about what kind of future we're building. Thanks for joining me for this week's deep dive into the best of hacker news. If you enjoyed this curation of the week's most important and engaging stories, make sure to subscribe. We'll be back next week with another selection of the discussions that are shaping the tech world. Until then, keep building, keep questioning, and maybe, just maybe, consider spending 6 years on something wonderfully impractical. Sometimes that's exactly what the world needs. This has been the Hacker News Weekly. I'm your host, and we'll see you next week.